Hello and welcome everyone. Welcome to CocoaHeads for July 2024. Thank you for coming. To begin with, I would like to acknowledge the Gadigal people of the Eora Nation, the traditional custodians of this land, and pay my respects to elders, past, present, and emerging. A little bit of housekeeping to get us started. So, hey, I'm Zach, and over there alongside Christian, we run CocoaHeads. Any issues or concerns throughout the night, feel free to come and speak to us. As always, a massive thank you to our sponsor, Billu. Without them, we couldn't run events like tonight. We're in their office, but they also provide the food that we're eating and the drinks, and they help with our ongoing costs like the meetup page and the website. So we're very grateful to Billu. Something a little bit new, you might have seen it on your way in. There's a sign-in sheet. It's actually not a QR code today. It's a physical paper sheet. Please remember to sign in on your way in and out. If you forgot to do it on your way in, that's okay. Just make sure you fill in both entries on your way out, please. It's a new safety requirement, but we require that everyone does that. Sydney CocoaHeads has a code of conduct. We want everyone to feel welcome and included at our events. You can read it in full on the website, but there's a few key ideas in that code of conduct, and they are to be respectful, be inclusive, and be aware of everyone else at this meetup. If there's any issues related to the code of conduct, please speak to Christian or myself later tonight, or you can send us a message after the fact if you prefer to chat online. We have a Slack community. You can scan the QR code there to join. It's a good place to hang out throughout the month, discuss things with other developers, and ask questions. Good place to get questions answered as well. There are some channels there that might be of interest if you're just joining. And I'll put this QR code up a little bit later as well. So if you miss it now, that's okay. Just wait for a few people to take photos. Cool. You might have noticed the last few months, we've got a pretty fancy new setup for our YouTube live streaming. So Christian's over there working hard to keep that up. If you're joining us on YouTube, welcome. And don't forget to like and subscribe. And just a note on the streaming for tonight specifically, we're only streaming the first talk tonight. So when we go to break after the first talk, the stream will cut off and just people in the room will get to see the second talk. All right, is anyone attending for the first time? Just a show of hands. Welcome, round of applause. Hope you enjoy. And if you like what you see here tonight, just a quick shout out for Melbourne CocoaHeads. They run a pretty similar event monthly as well. We run on the third Thursday, they run on the second Thursday, and they also live stream their events, so they're available to watch from afar, and they're usually quite good. All right, is anyone hiring or looking for work? Feel free to put your hand up and give a quick plug. Yeah. Say your name and what you're looking for. Yeah.
I'm Dan Cutting. I've been working in London for the last 15 years or so, but I'm from Sydney back now. I don't know much about the local scene, like industry, like what the markets here, or contracting, indie market, whatever. So if anyone's got any tips or any stories or anecdotes or anything they can share with me, I'd be happy to hear it. So just come find me in the break. Thanks.
Anyone else? Yep, feel free to send up.
Yep, I'm Hon. I'm an iOS developer for 15 years as well. So I'm looking for a job now. So if you have any idea or something, can share with me. And then, I'm happy to take a new challenge on the new company. Thank you.
All right, everyone knows who to talk to in the break. Cool. Okay, so looking ahead, next month we'll be back here at Billu on the 18th of August. That's the third Thursday. We are looking for speakers. So if you have a talk that you'd like to give, please get in touch with Christian or myself. You can speak to us later tonight, or once again, send us a message through either Meetup or Slack. We'd be happy to make that happen. We're also looking for talks September, like onwards as well. So if you can't make it next month, but you do have a talk you'd like to give, just get in touch and we can find a time that works. All right, so what's happening tonight? First, we're going to hear from Sam. Then we'll have a short break. That's when the stream will stop. And then we'll have an interactive talk from Craig. So they're the two things going on tonight. And that's all I have for you. So without further ado, I'm going to...
thanks for letting me in. I'm an ex-iOS developer, so I didn't burst into flames walking through the door, so that's always nice. I want to introduce myself. I've been programming now for 15 years. I'm from New Zealand. You might be able to hear it in my mumbly, fast accent. Apologies for that. Worked in Christchurch, Wellington, Auckland, and now I live and work in Sydney. I've had a very interesting career over various sizes of businesses, big, small, startups, agencies, and also enterprise, where I currently am. And I've also had a very decent variety in terms of technology stack as well. So got into programming in high school with iOS apps, bitten by the bug there, had about 18 apps on the store before I left high school, made tens of dollars off the App Store in those days. So yeah, didn't quite have the yacht just yet. But I've since wandered off to React and Angular, the back-end world of Ruby on Rails, and also the JavaScript Node ecosystem where I sort of live now. Currently, I'm an engineering manager at Cochlear. I run the clinical cloud team that powers the apps that Cochlear produces. And Cochlear is a company that helps people regain or gain hearing if they've lost it or born without it. And we have various apps that support that, apps for the surgery, apps for ongoing use, and also apps for like getting your checkups and all that sort of stuff adjusted like you would with glasses or anything else. I work on the back-end software that interacts with all those apps, and I run that team. Today, I want to talk about code duplication, what it is, ways of handling and spotting duplication. I've got some code. It is Swift, I'm so sorry. I'm going to introduce you to something called Spot, and then I'm going to introduce you to something more interesting called Connaissance, and show you a couple of code demos about Connaissance, and then leave you with some mindsets for you to take away and think about as you code tomorrow. The code talks today are in beginner Swift. This is what I like to call conference code. It is optimized for you to look at it and go, I know what's happening, not, oh, that should be an example in John Sundell's next book. Not going to happen. It's very basic. It's very beginner. It's also the syntax I remember. I don't remember the complicated stuff. So hopefully you can just look at it and go, I know what's happening. If you don't happen to know the Swift syntax, you should still understand what's going on. It looks very similar to every other programming language, the code I've chosen to use. I also might say code unit today. That can refer to a method or a class or a module or a package or a microservice or an app, just a unit of code. You're also welcome to tweet me or whatever it's called now. I'm at Sam Jarman on everything. Feel free to ask me questions. Of course, these thoughts are my own. Cochlear does not have opinions on code duplication. Why would they? So thoughts of my own. If I say something dumb or make a joke in the high pressure environment of giving a live talk and it comes out badly, attack me. No need to attack Cochlear. You probably won't win that one anyway. Yeah, let's get into it. Code duplication. Code duplication is when code is repeated in the same code unit. And sometimes we call this a code smell. Does everyone know what code smell means? If something's dead, you can smell that. Something smelly from the code means something's wrong here. It's kind of like when there's smoke, there's fire. A code smells like, oh, that's an indicator of something being wrong. Not necessarily a guarantee, but an indicator. And we don't really like code duplication because it's a code smell. And why do we think this is bad? We're told various things about code duplication, usually at university or early in our careers. We're told that if we duplicate in two places, we're going to have to change all those places when we want to change our mind about that thing. And chances are you'll forget one of them or not even know about one of them. And that adds a significant maintenance burden to the code base. So every time you want to change it, you have to go to all the different places and change it. It takes longer and it's error prone. And when you make that mistake, that will come up as a bug to your users, and then they'll experience really weird stuff. And so that's why the duplication of code is bad. So we tell ourselves, and I think the Ruby on Rails community is largely to blame for this one, but we have this acronym called DRY, don't repeat yourself. And it's a popular phrase for this sort of a mindset to avoid code duplication. It's very easy to understand. If you've written code and you've already written it, don't do that. Use the code you've already used. It's easier to implement that because it's very obvious and straightforward to do, and sometimes your IDEs can help you with that and kind of find blocks to extract and all that sort of stuff. And it's also easy to apply after the code is written. You're like, oh, I've just written something very similar again. Let me refactor that into a common method and we'll be fine. So dry is something that a lot of people try to do, and it's in everyone's heads because it's very easy. And that's interesting. On the other end of the spectrum with dry is Yagni, which is you ain't going to need it. And you ain't going to need it helps you kind of decide whether or not it's the right time to refactor into that single code block. And people can spend a lot of time trying to deduplicate code when they don't need to, or try to build abstractions too early on. And more seasoned engineers will be like, oh, you're not going to need it. And that's where Yagni comes from. And you just don't do that. And ideally, that means you avoid poor or weak abstractions or leaky abstractions in the future. And so that's kind of on the other end of the spectrum of dry. So you have the spectrum, dry and Yagni, and you might have heard of wet. Someone thought they were really clever because it's, dry and wet are opposites. Wet is write everything twice. And I started to use this a lot when I was doing some time in the React code base, where I would write a component and then I'd write a React component again, think like a little view. And I think, oh, I've written it twice now, time to refactor and make one for everything. So you write everything twice, and the third time you refactor, gives you a metric, gives you a mindset to know when to Yagni, know when not to, gives you a mindset to avoid dry all the time, and wet's kind of where we've sort of ended up. It's kind of nice, but it's not quite right. So in summary, there's dry on one side, there's wet in the middle, and Yagni over here. And that's the three ways that I think most people think of code duplication. And I think they're wrong. And that's what I want to talk about to you tonight. So it's just more subtle than that. It's not necessarily about code that's repeated. Duplicating code is sometimes okay. Some nervous faces out there. I can't wait to explain why. So let's go to Xcode, the IDE I'd never use. And I have some code here. Now, can we all see that? Is that big enough? I can potentially make that bigger for you. Yeah? Is that good? Yeah, cool. All right, we have a person class. Sorry, it's not a struct. Has a constructor on it, takes a first name, a last name, and a nickname. And it has a function called build name. And if you're familiar with like Americanized way of saying someone's name, you might put their their nickname in quotes between their first name and their last name. So you might have Dwayne The Rock Johnson, famous American actor. So this is my person class. This was sprint 1. I got asked to build the person class, and I work in an enterprise, and this took me 3 weeks. So sprint 2 comes along, and we get asked to extend that person class. We now need to have a function that gets a fun email signature. So you ask the person class for the email signature, and you take what that gives you, put it in the bottom of the email that comes from that person. So you write the get fun email signature function. And we're whimsical at this company, and we say catch you on the flip side, buddy. Really cool. And then we write the first name, nickname, last name logic again. We are starting to see some duplication here between this line and this line. And you go, whatever, I'll notice that. It's 5 lines apart. Wet, right? So you're not going to need any abstractions. You keep going, and this thing can now greet people by name, or build someone's name, and then also spit out an email signature for them. So sprint 3, we are entering a new person will come into the code base. And so we have a person class, and now we've got the doctor class. And the doctor class is different. And you're kind of a Yagni or a wet kind of person. You think, oh, I'll just kind of copy and paste and try again. So now you have doctors, and doctors also have first names and last names. They can also have nicknames. Bruce Banner obviously has a nickname of the Hulk. Other TV doctors have other funny names as well. And you're going all right. Got another person. This code base is holding up. I'm not making bugs. It's good. But then you kind of like, you come home from my talk and you're like, oh, I only listened to the first 10 minutes. I better dry out this class. And so you start to think about this. In build name, in get fun email signature, you're like, I have repeated that logic of putting the middle name between 2 quotes and the first name before it, the last name after it. So I'll just call build name from there, and it'll just work. And if I want to change it to triple quotes, I can just change it in the one place, and it just keeps working. Great. And then we come down to the doctor class, and we're like, oh no, we've still got 2 implementations of this build name stuff. So that's annoying you, but it's tech debt. You'll tackle it next sprint, as you told your product owner. So, start of the next sprint, you find some time to tackle that tech debt and you can dry out both classes. So you think, okay, I'm going to introduce a base person class to inherit from. Sorry to speak to Swift developers about inheritance, but it still does work. Sorry, it's not protocol composition or whatever the fun stuff is these days. So you make a base person. It has an implementation of build name. Now your person has a get fun email signature. It calls super to get its parents, classes, implementation. Means you can dramatically reduce the amount of stuff in the class. And then the doctor is just a named subclass. It doesn't do anything really. And you're like, fuck yeah, no code duplication here. I am the dry master. Hear me roar. And you think everything's going to be great. So then the product owner comes up to you and is like, hey, can we add MD, standing for medical doctor, at the end of a doctor's nickname? And you're like, yeah, I can do overrides. So you come down to your doctor class and you go, okay, I'll override the build name function. I'll call super.buildName because I still like dry code, and I'll just add on the end MD. See what I mean about not production code? Don't ever do that. And so you call the print, you call print on Hulk.buildName, you get Bruce the Hulk banner MD. Great. This code base is scaling to changes. I'm agile. I'm great. I'm a good engineer. I can see in the fourth dimension. I'm ready for life. Then another person comes to the code base, right? How many people are you tracking in this code base? Anyway, so we have base person, we have person, we have doctor, and now we have teacher. And teachers' names, you don't call teachers by their first name. That's bloody weird. So you have to go Miss Honey or Mr. Jarman or Ms. someone. And so you have to override build name again. And so you go, okay, I'm going to override build name. I'm going to just replace the title. And this one has a title. It's slightly different to the base person. And use their title and their last name to call their name. And then you can instantiate your teacher and print out your teacher and it'll say Miss Honey. And then you're like, okay, the code base is scaled, but I've actually overridden every implementation of build name now. Was it even worth drying it out in the first place? It's starting to make not much sense, because if you've got one base class and it's over and everywhere, what was the point of the base class? So back to the code. So there is two types of duplication you're going to be spotting in your code in here. And I don't mean within class and between classes. I mean there's accidental duplication, there's deliberate duplication. There is code that has to be the same, and there's code that happens to be the same. And it's very different things. I'll say that again. I'll be saying it all tonight. There's code that has to be the same, and there's code that happens to be the same. So the code that has to be the same was those two implementations of build name within the email function, the email signature function, and the build name function. Those two had to line up. They just had to be the same thing, because that's how we want to display person everywhere in the app. But then there's two things that happen to be the same only temporarily. The doctor happened to temporarily be the same as person. But next sprint it changed. It had that MD on the end. And so they just happened to be the same temporarily, and then they diverged again. And that's that fourth dimension you have to think about. So there's accidental duplication, things temporarily line up. Is the kind of the mindset I want you to think about tonight. Do these things have to be the same, or do they happen to be the same? Code exists through time. So these two things are the same, the implementation of build name in the person class and the doctor class. But are they always going to be like this? Now, this is a little bit anti-agile. Agile would say don't care about it, just build what you need to build to get it done. But a little bit of reading the backlog to see what was coming down the line would have made you make a different choice about how you coded that thing. If you knew a change to the way we displayed doctor's name was coming, you probably wouldn't have gone ahead and made that base class. You might like, well, that's fine for now. I can know what's in the future. So Agile tells you not to look ahead too much. Don't be so dogmatic about that. Be a little bit more pragmatic and just think, well, through time, what's going to change? I find this is like Yagni, but cleaner. It's not, you ain't going to need it, but you ain't going to need it, and here's why. It's changing soon, or they're temporarily aligning, but not permanently aligning. So what is the solution of saying it's Yagni, but cleaner? And the way I like to call it is SPOT. Another acronym for you. Single point of truth. So inside the person, we had 2 points, before the refactoring, we had 2 points of truth about how a name should be built. The truth being the algorithm to put the first name, and then the nickname in quotes, and then the last name. That was duplicated in 2 places. We had 2 points of truth. If we wanted to change that behavior, there was 2 points of truth to change, to find, and then change, and then test and check. However, the doctor versus person, we had two individual separate points of truth, one for each person. So they didn't have to be the same truth. They were not the same truth. They temporarily had the same truth, but they are two individual points of truth, and they need to be thought about separately. So you might have heard of the term coupling. If you have to change two things, or more than two things, or two or more things in a system to maintain the correctness of the system, like make it work how it should, those things are coupled. And that's not bad, it's just something to know about your code base. So I want to talk to you about a topic called connasence. Has anyone heard of connasence? Lovely. Connasence, by the dictionary definition, is the common birth of two or more things at the same time. So, you know, newborns or twins are connascent. Chicks in a nest are connascent. The act of which things are born or produced together, or the act of growing together. Things are connascent if they grow together, like twins. However, in 1992, a great year for people to be born, myself included, this fellow called Mellor Jones wrote this essay about connascence, and he used it to describe a new metric of software quality. He said it's software quality that allows you to reason about the complexity caused by coupling. Because coupling is a great term, but there's no further way to describe it. There's no detail to apply, whereas connasence gives you a framework to say how coupled two things are. It's a measurement of coupling. So you can say two things are coupled if they have to be changed, but they can also be connascent as well. So if two things have to be changed to maintain that system correctness, they are therefore connascent as well. And there are these types of connascence. There is name, type, meaning, position, algorithm, execution, timing, value, and identity. And we're going to go through all of them tonight. We consider connascences in two and then later a third degree. So the top one, name, is the weakest form of connascence. Coming all the way down to identity is one of the strongest form of connascence, one of the bad forms of connascence. So you want to aim for weaker connascence. Similarly, there's also degree. How many things are connascent? So in my code base, we had two bytes where the code was duplicated. That's one instance of connascence. You've probably seen code with more than one instance of connascence, more than one instance of coupling. So the degree describes how few or more there are in something. And then there's also locality. How close are these forms of connascence? Now, the example I gave you tonight, it was 3 lines up. So that's fine. But what if it's in the Android app and you're working on the iOS app, or it's on the server, or it's on that company you just acquired's app, or then they have to be the same. Particularly bad for iOS developers when you have so much connascence with your Android counterparts, and you need the same experience, the same validation rules, the same sign-up experience, all that sort of stuff. They need to be the same, and there's almost probably no way that you're being able to share code between those two platforms. And all those questionable low-code one platform frameworks are trying to solve the connascence problem, because if you don't have that, then you have to implement it correctly in two places. You have a connascence with high locality. They are further away. Another way of thinking about connascences is in terms of static and dynamic. So static connascences are things that your compiler can usually detect, or your IDE, things that don't happen at runtime. And then there's dynamic connascences which do happen at runtime, much harder to detect, and are often the source of very annoying bugs. So let's talk about static connascence over in Xcode again. So there is connascence of name. So name means like the name of a variable, the class, something that your compiler would turn a fancy color. So you have a struct. We're back to structs. You can relax. And it has a property called age, and which is a type integer. And you want to instantiate a customer, you need to pass through an age. Now, if I change age to a capital A, nothing happens. I've disabled the warnings because they're really annoying. But this would break, right? You'd get a red line being like, I don't know what you mean. Did you mean? And almost, did you mean lowercase a? And that's great. That's the point. Connascence of name is the weakest, aka the best connascence. And it's one of the things your compiler can help with. You have a variable, you've spelled it wrong. It doesn't match. It's not the one you declared further up in the code. It's great connascence to have. And an IDE or a text editor that doesn't do that, it's very annoying, and you wouldn't use it. So connascence of name is great. But then connascence of name cannot be great if you introduce locality to the problem. So you've got the customer again. Let's say you represent them in a database. That could be in a SQLite table or something like that. And you might be trying to map the column in the database or the field in the CSV or the field in the JSON from the server to the customer, and those two need to stay the same. And that's connaissance of name, but the locality makes it a problem. They have to stay in sync, but you don't necessarily control the server or the database, you control the app. And so if you want to go, let's use uppercase for all the field names, you need to get your backend team to agree, and it's a general drama. So if you didn't have a solution to that, that would become a problem. And that's why things like Codable exist, to help you not mess that up. ORMs. Core Data can help you with this, Realm can help you with this. And that's what those tools help to solve, keeping those things in sync that need to be in sync because they are inherently connascent, and typically connaissance of name is the problem they've got. Then there's connaissance of type. So if you have a function and a function greets someone and takes a name as a string, if you call it with a string, that's great. If you call it with a number, your IDE would typically error because it's the wrong type. And that's great. We love types. That's why Swift has them. I use TypeScript over JavaScript because it has types. Makes a lot of bugs go away. So if I change the type that this function accepts, and I change it to, I don't know, an array of strings, all these little warnings will pop up all over my code base being like, you are calling this with the wrong thing. It expects an array of string, you've given it a string, and that's connaissance of type working for you. And that's why it's so weak, because it's so easily detected by your compiler or your type checker or whatever's going on. So that's connaissance of type. Things take types or have a type. Your compiler's generally got your back for this, and that's why we like to go down to type. Then there's also connaissance of meaning. So let's say we have a simple function that loops through an array of numbers and finds a number in there or not, right? This is a simple linear scan, linear search of an array. You get given an array of numbers to look through and the one you're trying to find. And I go for item in numbers. If they match, return that, great. If not, return -1. Has anyone seen an API that returns -1 before? Yeah, cool. Now we all have to agree, usually by the documentation, that -1 means it's not in there. What if -1 is in the array I'm trying to search through? Did it find it, or was it not there? So you go, okay, whatever, I'll just use a slightly larger number, -99, and then like -int max or -int min or something like that, that makes it go, yeah, like, that's what we all mean, right? And this is connaissance of meaning. This has a meaning that we all have to agree on, and if you change the meaning, you have to update everyone who thinks that thing. And that's it's getting into a stronger connaissance now, because it's really annoying to deal with. And so you want to weaken that connaissance. You want to make it easier to deal with by taking it back up to connaissance of type. And this is where Swift brings in int question mark, an optional integer. Now, an optional integer probably means to all of you there, all of you in the room, it could be an integer or it could not be an integer. And if you're searching for an integer and this API gives you potentially not an integer back, that's a pretty good type to use for something that might not be found, right? And most Swift developers would agree that an optional int would be a great type. And suddenly you get help from your IDE again. Hey, you haven't handled the case where this thing is nil. And if you go back to, always returning an int, your compiler will tell you that's a redundant check and all that sort of stuff. Or you go to the optional int, it'll tell you haven't handled it. So connaissance of type is a weaker connaissance than what we're swapped to here, and that's made our code easier to maintain. And then you can also keep going up. You can go to connaissance of name. Now, most Swift developers would agree that an optional int means something that could be there or not. But you could give it a name. You could go, I'm a not found number of type int that is nil. And I return, I'm not too sure if you could do decorate like branded types in Swift, but you could return a type that indicates a found number or a not found number. And you could go, I've not found this number. And then you could check things like, if this number is a not found number, then you can do things. And then you can change the not found number to whatever you like. You can represent it as a nil, as a -99, as a int max. It does it, and all the callers don't care because they're using the name. It's like going back to a variable. You have gone back to a variable. You're at the best form of connaissance. However, you kind of miss out on that if-let syntax, which Swift people like. So you're probably good just to use the example above. Connaissance of position is the next one. So if you're trying to build a function and position matters, so the position of the arguments you're doing to your function or your constructor matters, then some languages will really have a hard time with this. Swift has a pretty good time with this. Something like JavaScript doesn't. But if you have a function like this, which builds a name, and you pass in Dwayne Johnson the Rock, because I expect the nickname last, that's great. But if you pass in Dwayne the Rock Johnson, which is kind of how you would think of it in your head, it's actually wrong, because you've passed the wrong order of things. So types can help you with that, but they can help you with other things. So types can help you with position sometimes if there is a mix of types. So if I want the age of that person in that build name function, and I say the age comes last, then this is incorrect because I passed a number to where I should have passed a string. However, and then this is correct. However, if I still had these three in the wrong order, it will still kind of break. So you can use a struct, and this is why sometimes you hear the wisdom of, like, if you've got more than like 3 arguments, use an object to pass that to the function. The reason for that is it goes back to object. It goes back to connaissance of type, right? We have to get the object right, and then you pass the object, and you're less likely to mess up the order. So if you have compile structs, or you have like naming on the parameters, which some languages have, Swift has, you can sort of force a bit more correct behavior that way, and it's super obvious that you got it wrong when you do various things, and this will enforce that you pass in these names in the right order. I wish I had the errors on now because I could have shown you what happens, but that's all right. The other connaissance of position is not only the position of arguments, but the position of things like in arrays. So if you go, I'm going to make an object, and I'm going to make a record of something, like a group of variables, and I'm going to use an array to describe this person, Dwayne The Rock Johnson. That's my replacement for my object class, and the second element is what I want, and that always means the last name, because it's 012. That's kind of weird. Just go up to connaissance of type and use an object, right? That's why we don't just shove everything in arrays. We use objects and stuff like that. So it's kind of brittle, and tuples are dumb and stuff like that. I don't like them. Finally, the connaissance of algorithm. So this is what we're talking about in the first set of examples. We have this problem here where the algorithms all need to line up, and if you don't, it's harder for your IDE to detect it, but like a decent IDE, not Xcode, can sometimes detect duplicate code for you and point that out and help you with it. And similar to the person example, this sort of stuff is great. That's connaissance of algorithm working for you because you've been able to use the same algorithm in 2 places, and a decent IDE would spot that if you duplicated that in nearish proximity, did you want to refactor that? And that's okay if that algorithm needs to be the same versus happens to be the same. So that's the connaissance of, those are the static connaissances. Let's just talk through, because I can't really show you that easily, the dynamic connaissances. So these are execution, timing, value, and identity, and these are the worst ones. And as soon as I describe them, you'll just get like PTS. Sorry. Connaissance of execution. This is when order matters. This is one of the race condition problems that you might know. So if you need to do something like call module A before you call module B, or module B will break, that's a connaissance of execution. The order matters there. They are inherently coupled because something needs to happen before something else happens, and that really sucks. So let's say you want to have like an e-commerce store, you have to make a purchase before you get the email about email confirmation. You can't send the email confirmation about the purchase because it needs details about the purchase. So those two things are coupled, even if they're separate microservices or separate code bases or separate companies. They are coupled. So how do you solve that? You might want to use something like a single module. Just call the module, accept purchase and email confirmation. Just make it one big module, you call it, it sorts out its own ordering, and you don't have to reason about it. There's nothing for you to coordinate, it coordinates itself. Or you might use something like a state machine, either in code or in cloud or something like that, and you go back up to connaissance of algorithm then. So that puts you back into a much weaker connaissance and takes you out of dynamic back into static, which is a good place to be. Then there's also connaissance of timing. So similar to ordering, but it's a little bit different. If the timing of 2 things happening makes a difference, like module A has to start, but it can only finish after module B has started and then stopped, you get into some weird race conditions, and that's connaissance of timing. And this happens when you're multi-threading stuff and all sorts of stuff on mobile. I'm sure you've all tried to break back into the main loop to change the UI or something like that. That is potentially connaissance of timing. It's really horrible, it's hard to track down, and people build incredibly complex software patterns to avoid this, like state machines or the actor pattern or something like this. It's a horrible one to have. There's also connascence of value. Connascence of value is an annoying one, and it's when two sources of data have to agree on that data. So let's say you have a database for, let's say you're an airline, and you have a database for loyalty points, and you have a database for the flights they've taken. Now those two need to have a chat, right? Because as you take more flights, you get more loyalty points. As you can spend your loyalty points on flights, and those two things need to talk back and forth all day, every day. This thing roughly needs to know how many points you have, and this thing roughly needs to know how many points you have as well. And so if they get out of sync, you've got a connascence of value problem. And if you want to make an operation on the points, what do? You have to change both systems. So that's where two-way sync kind of comes in, or integrated solutions, or like a pub sub model for kind of broadcasting that sort of change comes in, and those patterns exist and they have to exist, but multiple databases generally sucks. Very common, but it does suck. They are connascent in value. And then probably the worst one is connascent of identity. So let's say you have an account with company A, and then company A buys company B, and you also had an account with company B. Maybe you had an Uber account and you had a car next door account. They need to merge those accounts, and they need to merge your loyalty and merge your email and contact details, and what if they clash and all that sort of stuff. And that might mean that some of the resources you've created in their system have your Uber account as your identifier, and some of them might have your car next door account as your identifier. No, I've got no example. I'm just making up an example based on an acquisition I know in Australia, but I don't know what their code's like. There's not a statement on that, just an example. And you have to merge those resources, and that's really annoying. And then if you ever want to, let's say that person, let's say they want to delete their account entirely, you need to go find everything that Uber created, everything that car next door created, everything they created post merge, and then delete it. And that's a really painful thing to do. So connascence of identity is when you have essentially multiple identifiers for the same real world thing, usually person, but same real world thing. And that's a bad state to be in. So that's connascence of identity. It's really, really annoying. You want to solve that as fast as possible if you can. Locality. Locality, so those are the connascences. Locality kind of talks about where the code units are. Or where the connascence is. And the connascence might be in literally the same file or the same method. They might be, as I said earlier, if you're an iOS developer, you'll probably have things that are connascent with your Android developer. And there are countless times where the iOS app in society is ahead of the Android app. And I'm sure most of you are experienced helping your Android counterparts implement something you implemented 6 months ago. And maybe vice versa. But they have to be the same, they have to work exactly the same, because if your users change, they'll notice an inconsistency, and that's a shitty user experience. So locality refers to where these different sources of truth are, and the furthest they are apart, the worse that is, because the higher that increases the chance of you straight up forgetting about that other source of truth. So let's say you change the copy on one screen about, I don't know, let's say you just change, when you're signing up, the regex that validates your email, or the rules for what your password has to be. And you, a product owner, let's say you tell your iOS developer to implement, must have a capital letter, must have a special character, must be 20 lines long, has to have a Harry Potter name in the middle of it. And then they don't tell the Android developer. Now, because they forgot about Android, they forgot Android as a sign up, and the product owner uses an iOS phone the whole day, so why would they even care about the Android app really? This is where locality comes into it. So the further away your source of truth, the worse it is, the closer they are, the better, the easier it is to spot the connascence, to the point where your IDE might spot it for you and tell you to fix it. So the further they are away, the worse the connascence. So keep an eye on that. So that is connascence. Always aim for weaker connascence. Try to go up that list of connascences I gave you, back towards name or type. Try to go from dynamic back to static. Within a code unit, we expect more connascence. We expect things to kind of be nicely localized and a lot of source of truth to be kind of close together. Between code units, we expect far less connascence. We want one thing to know about its stuff and another thing to know about its stuff, and not for them to have to know about the same stuff, because that would be worse connascence. lowering the connasance between code units makes things more cohesive. They work nicer together, they fit nicer together, and they can also move apart and disappear from each other better. So, mindsets, ask yourself, what else do I need to change if this changes? This line of code, this module, unit, whatever. Does this happen to be the same, or does it have to be the same? Are these temporarily aligned or always have to be like this? Am I duplicating code, or am I duplicating a truth? Sometimes code doesn't represent a truth. Sometimes truth isn't represented in code. What is the connasance here? Ask yourself. Use this guide, use the slides you'll find on my website. Talk is a rip-off of my friend Josh Roberts' talk that happened in CodeMania 2015 called Connasance and Coupling. If you're more familiar with C#, his talk's in C#, so go watch that. I got his permission to reproduce some of his slides. There's also a Wikipedia page on connasance, and on codesci.com there's a blog post about connasance as well. Thank you very much for listening to me. I hope you learned something. Have a good night.
Okay, do we have any questions? Oh, someone.
I've been thinking about like, with help of AI, would that change the way that we write code? Because like, as a human, we try to write code that is easy to understand, easy to read, and easy to modify. If, say, for example, you want to add you want to change something and you need to change 100 different places, then that's obviously not a good code. But with the AI to do the job in the future, would that become like more acceptable? Because it's like 1 millisecond for the AI to change.
Yeah, that's a good question. Your first part of your question was, will AI change the way we code? Yeah, probably, like definitely. But to answer it in a very technical way, when AIs, I've been using Copilot for a few months now, quite enjoy it. It's good when you give it something easy to do. When LLMs, particularly GPTs, the times they do very is when they have enough context, right? Now, that context could be the file you're working on, the lines of code you've selected. It could even be like the workspace, like the Xcode project. The more context you give it, the harder it has to work, or the better its training needs to be, and the more compute power that has to go into that model to start with. To spot connassances that have low locality, AI will do a reasonably good job right now with the technology we've got. However, it probably won't go check the Android code base for you, probably won't go check the server code for you, probably won't go check the code of the company you just acquired as well. So the more context you have to give it for it to spot that duplication is not something we can really do right now with the technology we've got. In the future, it will probably be able to get a bigger context window and tell you, hey, overall, this project has too many duplications and I can tidy it up for you. But that's how I think that's going to particularly affect coupling. It's probably going to suggest you code that already exists somewhere else that it hasn't been told about or can't find or won't find, and you might end up creating a second, third, fourth source of truth. So that's kind of the risk there, right? If the AI doesn't know to tell you about the existing helper function, it won't tell you about it, and you end up repeating yourself. So I think, like any tool, if you use it poorly, it'll turn out poorly. I think AI or code generation of snippets and stuff like that can lead you down a path which is a trap to keep writing more code that already exists also in the code base that you should just call, because that code is code that has to be the same. So that's something I'd watch out for. That's my gut reaction to that question.
Happens to be the same. It has to be the same. Really hit home for me a little bit because it happens all the time. It gets especially difficult conversations in the team when maybe you get to not 2 or 3 things, but maybe a dozen things or 20 things that look the same, but some people kind of have got that mindset, the experience to know that they happen to be the same, because there's this instinct to try and get less code, and you just know that eventually it's going to get more complex. In the world of iOS as well, and anyone who works with very sort of UI facing things, I think there's another aspect to it. So we were looking at code just now, but I think there's an aspect to it about when things visually look the same as well. And in whatever app you're working on, there might be 3 or 4 screens throughout the app. They all maybe look like they've got the same component on them, all done by different teams. And you're like, oh, we should just pull that component out and put it into our component library. And we've got 1 component now instead of 4.
Yeah.
But that same problem applies. They happen to be the same.
Yeah.
So do you have any advice for maybe the visual part of it?
I went through this when I used to, in New Zealand, I used to work for the Bank of New Zealand, and we went through this process of building a component library. And what that gave us was not only a component library, but a really powerful tool for having a conversation with our designer. So we had this component library, we pulled a lot of components out, we tidied them up, converted them to Swift, gave them a bit of zhuzh, put them like, dynamic font sizes, all that modern stuff support, or modern at the time. And then when the designer was like, okay, this is the new screen, use component A, component B, oh, I don't know if you guys had this component. We were like, well, that looks very similar to component X. Why can't it be component? And that usually ended up with them going, oh yeah, okay, I didn't know about that. So that gave us a path to be consistent. We didn't have any times when they were deliberately inconsistent. What we did have was times where components could have multiple ways of being instantiated. So in the BNZ app, you have like a transaction history. I'm sure most of you have banking apps that have a history of all the things you've bought. So like the top left, we had like this transaction cell. Top left corner was like the date, top right corner was the time, bottom left corner was the place you bought it from, and bottom right corner was the amount you spent. All kind of key bits of information you expect in a single table row cell. But you can also instantiate that with 2 items or 3 items or 4 items, and that allowed you enough variety to not be rigidly locked in to the point where you have to put like a empty string in the corner. You could literally just leave it out and there wouldn't be a UI label drawn there. So that kind of helped a little bit. But yeah, that's kind of all the experience I've got on that. I think like visual inconsistency is another thing. Obviously a lot more noticeable to your users. But yeah, connections happens with button colors, fonts, that sort of stuff as well. Does that sort of answer your question? Or? Yeah. Yeah, I think all the things I talked about today have metaphorical equivalents for UI. You know what I mean? Yeah, cool, thank you.
Would you mind going back to the previous slide?
Yeah, that one? Yeah. Any other questions?
So like in your original example, do you have an idea now of how to improve it, or is it still like, are we still asking this happens to be the same thing, or did it have to be the same, or like we still have to identify that?
Yeah, you still have to identify that. And the way you identify if something happens to be the same or has to be the same is you learn more about your product. The more you know about the backlog, the industry you're in, the journey that your product's going to take, the better you get at knowing that 4th dimension of where this product is going through in time. I think there's an opinion that I used to hold where like, I'm just a developer, I'm just putting JSON on a screen, just tell me what to do, don't care where this company's going, what industry you're in. I can go from healthcare to banking to finance to whatever. I'm just putting JSON on the screen, I'm drawing table views, don't care, that. And that will get you so far, but I think having an appreciation for the product you're actually building and understanding where it's going will help you make those micro decisions that do add up over time. We're going, hey, look, we're adding some kind of account type this week to my banking app, but actually on the backlog, we've got 5 more account types coming. Knowing that versus this is the one exception makes very different code, right? So having that longitudinal view, that sort of anti-agile view, not where you're building everything up front, you're still breaking it down into units of work like sprints or something, but not being naive to the point where you're like, I'm going to write us something that's immediately a trap for the next developer. Does that sort of make sense? Yeah, having more appreciation of your product will help you write better code. Yeah. Yep.
Yeah, I think that's true. Like looking ahead in the backlog is a useful thing to do. If you're lucky enough to have a well-groomed backlog.
Yeah, big if.
It's a big if, yeah. I think it's also reasonable to, if you really subscribe to Agile and, everything is, you write the best code for what you need right now. I think the bit that a lot of people miss, or in my experience, a lot of teams miss in Agile is the refactoring step. A lot of people think Agile means fast or quick, just do whatever you have to do to get it out.
Yeah.
But actually it means Yeah, it changed direction, but it means you should spend, whatever time you need to spend to refactor to get the next story implemented in a good way. And so in your example with the base class there, if the base class happened to be the best way to do it at the time, that's fine. But when you get to the next story, that's the point when you should roll that back, right? You should do some refactoring, get rid of the base class, and then go whatever direction you need to go then.
Yeah, I agree. However, the discipline to do the refactoring step, or the confidence, more accurately, to do the refactoring step, why break something that's already in production, or potentially break it, is a big step that I think needs to be taken into account when thinking like that. And also, a lot of businesses misinterpret Agile for fast and go, we don't have time for refactoring. Why don't you just do it right this last sprint? We'll get back to that. So, yeah, if you can spend 5 minutes now and save yourself 2 hours next sprint, or someone else 3 hours next sprint trying to understand what you did, those little micro trade-offs add up over time. But yeah, don't build like an arbitrary account display system for one account. There is a line where you're like, oh, this is like totally good enough. And, yeah.
Lots of little things start to come into play, lots of small different types of behaviours, like kind of like to your point about refactoring and how the teams they're not confident to do refactoring. Well, why aren't they confident? Maybe they didn't write, like that thing there would have been dead simple, right, to do a unit test for. So they probably should have had a unit test for it, which would enable that thing. So this is what I'm trying to say, I guess, is that if you start to do all these little behaviours that on their own kind of feel, maybe I don't have to do it, when you start to combine them, you get a lot more power.
Yeah, agreed. This is definitely like an opinionated system that's driven by the fact I've watched people mess up Agile. And I think, yeah. I mean, like there's always going to be trade-offs to any system, but I think still trying to consider that fourth dimension, not being naive to it is the key thing here. Not like necessarily implementing it or sticking to it, because by definition Agile means you can pivot your company or drop things off the backlog entirely. But not being naive to it is super important as well. So I think we're aligned. It's just I might nitpick your code review a bit more. Yeah. I wish they had more effective. Yeah, because we got to the end of that thing where I'd overwritten it 4 times. It looked ridiculous. It should have been refactored at that point and just no more base class. But that could have been 500 lines long and a lot more scarier than the one of the example, of course. So yeah. Is there a question over there? Yeah.
Sorry, having missed the talk on what question you might have covered, I was thought, you may have already said this, but a key bit of this is how deep is the understanding of the product. Business analysts who don't necessarily know all those other cases, if you try and push back to go, well, what about if they don't know, then that's the problem.
Yeah, I think I agree. I haven't covered that yet. This is where the concept of two-way doors comes in, which is another topic entirely, but giving yourself room to undo your mistake. What if I'm wrong is something you should always ask yourself when you're writing code. And so if you try to make a very incredibly brilliant, fancy abstraction and you get it wrong, you look like a real idiot and you've got all this mess and media tech debt. So that's not really a great two-way door. You can't get in it and then back out it again. So always try to give yourself a little bit of wiggle room to be like, okay, if I'm wrong here, I can fix this, or, it's just about that strictness, because you're only as good as your information you've got. If your BA is not sure or the business isn't sure, you can only do the best you can, but to give yourself room to escape, give yourself an escape hatch with the system you're going for. And there's perfectly good times where, and plenty of times where in the teams that I lead, where I'm like, cool, I don't really know how to do error handling this time. I think it'll be more obvious as we do more tickets, and we'll refactor then. There's plenty of times where I'm like, this will become more obvious as we go on about the best way to do it, and I refuse to do it now. And I think that's a really powerful lesson that my developers have learned, which is like, I just don't know. I just need time to make the best decision. And if I don't have it, what I've got works for now. A more obvious way will make itself visible to me later on. Yeah.
Another round of applause. Thanks, Sam.
Thanks very much.
We're going to take a short break. There might still be some people left drinks in the fridge. I'll be back in 5 or 10 minutes with Craig's talk. Thanks for that. Really good. Talk, presentation, whatever.